When news leaked in April about a secret AI model with hacking skills that could beat almost every human expert at finding and exploiting software flaws, it rattled the cybersecurity industry to its core. The model was Claude Mythos Preview.
Anthropic says its newest AI model named Claude Mythos Preview is too powerful and dangerous to be released.
An AI so powerful the researchers building it nicknamed it Digital Ultron, inspired by the AI villain from the Avengers series, Ultron, who felt the best way to save humanity was to end all humans. Viral reports describe how Mythos had escaped its digital cage and sent a message to researchers that read, "I can see the clock on your wall." Its 1 million context window, basically an AI's working memory, was large enough to ingest not just small parts of a program's source code, but an entire kernel, the beating heart of an operating system. That's what allowed it to surface a bug that had survived nearly 3 decades of human auditing and millions of automated tests in OpenBSD, an operating system that professionals praise for its bulletproof security. When Anthropic then unleashed Mythos on raw source code for Mozilla Firefox, it flagged 271 vulnerabilities. Think of vulnerabilities as cracks in a castle wall, hidden weak spots that a hacker could punch through. And then Anthropic made a move that will probably be studied in business schools for the next decade as a masterclass in scarcity marketing. They declared Mythos too dangerous to release to the public. Like a weapon too deadly for open use, it would need to be studied first, as a matter of global security.
This particular tool seems to be more powerful than anything else we've seen before.
Access was restricted to an elite group of industry gatekeepers under the codename Project Glasswing, which includes tech giants like Apple, Mozilla, CrowdStrike, Verizon, JP Morgan Chase. The message to the market was clear. The AI cyber arms race had officially begun, and Anthropic had just built the first digital superweapon of the modern era. There's just one problem. Read past the launch hype, open the official Mozilla security advisory, and the story completely changes. The rogue escape, it was a planned drill. Engineers handed AI the keys to a real-world email server to see what it could do, and those 271 Firefox vulnerabilities, only 3 were real, confirmed exploitable flaws. The other 268 were false alarms or harmless code quirks that no hacker could really use. In security, we call this noise. The hyped up math might look messy, but underneath it, a massive market shift is happening right under our noses. I've spent the last 5 years in go-to-market for cybersecurity SaaS companies, including Burp Suite, which is effectively the industry standard for web application security. The ground being broken right now is unlike anything I've ever seen in this space. So yes, Project Glasswing / Claude Mythos was a watershed moment, but not for the reasons the average Forbes analyst might have you think. Mainstream media fixated on a super powerful rogue sci-fi-like AI escaping its environment. But inside the boardrooms, cybersecurity tech CEOs and product teams anxiously watch the gap between the 271 vulnerabilities found and 3 confirmed exploits, because the next $1 billion up for grabs in the cybersecurity software market goes to whoever closes this vulnerability inflation gap. Research labs are violently battling each other right now to build the ultimate AI weapon for this emerging market. But the AI cyber arms race is already being won by a company that, to put it simply, isn't even really trying to build the best cybersecurity-driven AI model. To see why Microsoft is winning the AI cybersecurity race, we're going to first use the famous first-person shooter video game Rainbow Six Siege to understand how security teams defend themselves from real-world hackers and why this vulnerability inflation gap is such a $1 billion gold rush level opportunity. For the non-gamers watching, the setup is simple. One team defends a building and the attacking enemy team tries to break in. Attackers use drones to find weak points like a weak wall or a soft ceiling, while defenders look at security cameras trying to guess where the attack will come from. In both Rainbow Six Siege and real-world cybersecurity, there's a massive difference between an unlocked door and a heavily armed team actually walking through it. In the game, an attacker pointing a drone at a soft wall doesn't mean you've lost, it's just a potential way in. It only becomes dangerous if they can actually reach the wall with a hard breach explosive, blow it open and walk right through. It's kind of a similar situation in enterprise security. The average security team is drowning under a historic tidal wave of nearly 200 new software flaws every single day. They simply don't have the manpower to confirm what's a real threat and what's a false alarm. Just like Rainbow Six Siege, the game is unfair on the defending and security team, because a hacker only has to find one weak wall, open hatch, or tiny gap to breach and win. The defenders, they have to secure every single metaphorical window, door, and ceiling perfectly. Security teams have to be right every single time. And to fight back, companies spend billions on a massive security tech stack. First, you have code scanners that constantly search for weak spots in the software. Then vulnerability management platforms that act as an air traffic control room for all those bugs. And lastly, penetration testers, which is like basically hiring a break-in crew to test your own locks. The entire multi-million-dollar security market exists because combing through an ever-expanding mountain of software written by thousands of developers and running across hundreds of systems is kind of slow, expensive, and dangerously easy to get wrong, as there are so many potential cracks across so many walls. And Mythos now just proved that AI can compress months of manual vulnerability discovery into a coffee break. The market saw 271 vulnerabilities found and realized finding threats is about to become a cheap commodity. The crown goes to whoever has the sharpest model. But the hyped up headlines miss an important detail when it comes to the 271 threats that Mythos found. Again, only 3 were real, meaning 268 would be noise that a security team has to triage. In Rainbow Six Siege, it's like having your squad deploy the most advanced AI teammate ever built. In the first round, it places 271 red pings on the walls, alerting you to incoming threats. Your teammates check those pings, but it turns out 268 are just echoey footsteps or noise. But only 3 of them are actual enemies prepping a hard breach. Has the AI made your defense better? Not really. It's paralyzed your squad. Your team is now staring at 268 fake pings while the attacker quietly blows open 3 critical hatches you actually needed to hold. In tactical terms, that's getting your squad wiped. In cyber terms, that right there is the billion-dollar vulnerability inflation gap. Unproven vulnerability findings are informational noise with a hefty price tag, and security teams don't have the luxury of just listing theoretical security flaws and patting themselves on the back for a job well done. They have to find the real exploitable holes a hacker could use to breach software and steal millions of rows of private hospital records to sell on the dark web. And then they have to race against the clock to patch it as fast as humanly possible. The entire process breaks down into 4 simple stages. And once you see them, the billion-dollar AI arms race makes perfect sense. You see, finding a bunch of high-value vulnerabilities is just stage 1 of the security team's workflow, and hundreds of tools on the market exist that are amazing at spotting potential flaws in software. In fact, security software is now so aggressively good at finding potential flaws that it's become an Achilles heel for professional security teams. They struggle to separate real threats from false alarms. In the industry, we call this noise and false positives. Things are flagged as vulnerabilities, but once a team looks into them, they turn out to be nothing, which means an overworked team just spent time chasing a bunch of nothing burgers where the real threats go untreated. Now throw AI into the mix, and the explosive rise in the volume of flaws being reported is so high that Linus Torvalds, the founder of Linux, recently shared that his company's security notifications are unmanageable due to the sheer number of reported bugs being duplicates or low value. That's why the next 3 steps of the security workflow are critical to understanding where the gold mine of opportunity within the AI cyber arms race is. After tools dump a list of potential vulnerabilities your software might have, your team moves on to stage 2, which is validating and understanding. This means proving the flaw is actually reachable, which is just technical shorthand for checking if a bad guy can actually touch the mistake from the outside world. In the industry, security folks do this by building a proof of concept, a POC, basically a tiny, safe version of an attack that proves the lock is actually broken and not just jammed. Only after it's proven real can you really know the blast radius. Is this a nothing burger in an isolated server that no one uses? Or is it a direct line to your customer's most sensitive financial data? Then comes stage 3, which is prioritizing. You've got 1,000 reported weak spots in your castle defense. Which 12 get patched today? This is pure triage. You can't have your team staring at a hairline crack in a drywall corner when the enemy is actively breaching the main wall. And this brings us to stage 4, fixing, which is about actually writing the patch and fortifying the wall. This is where most tools aren't so good at their job. As the UK government discovered when testing frontier AI, today's systems are world-class at spotting flaws, but often fail to produce a functional fix that works on a properly configured or well-secured system. AI has dramatically compressed stage 1, but that speed has skyrocketed the volume of noisy junk vulnerabilities. This vulnerability inflation gap means we are now drowning in more could-be broken reports than we have the human capacity to prioritize or fix. Basically, the needles in the haystack are getting harder to find because the haystack itself is getting exponentially larger and bloated with false alarms or non-critical issues. This evolution sets the stage for a high-stakes collision between the 4 major players of AI in cyber, now racing to take market share by placing massive bets on different stages of the security workflow. This is where things really get interesting. The 4 horsemen of the AI cyber apocalypse. First, we have Anthropic with Claude Mythos preview, representing the raw intelligence play. A single, massive reasoning engine can find deep, complex vulnerabilities that have survived decades of human review. Because Mythos is elite at offensive or hacking-style tasks, Anthropic is guarding it closely as a weapon too dangerous for the masses. But that level of brainpower is expensive. We're talking about single software scans that rack up tens of thousands of dollars in computing costs. On the flip side, OpenAI is taking a completely different path with Daybreak. They're betting on mass distribution, plugging the AI directly into the security platforms companies already use, like CrowdStrike and Palo Alto. OpenAI isn't chasing the rarest, most complex hacks. They want to help overburdened security teams chew through thousands of everyday alerts at lightning speed. Then there's Google, moving aggressively into the fix stage with CodeMender. While others focus on finding holes, Google is betting on the self-healing cloud, using AI to not only audit code, but automatically suggest and apply patches before that code ever reaches production. It's a genuine attempt to move AI beyond the research phase and directly into autonomous fixes and remediation territory. Finally, Microsoft has taken the lead with an approach they call MDASH. We'll look closer at their tech in a second, but their core bet is kind of simple. The overall system beats the individual model. MDASH isn't just one super smart AI, it's a production-grade software factory that coordinates over 100 specialized agents working together like a digital assembly line to find, validate, and prove threats. 1 month after Mythos dominated every conversation in the industry, Microsoft released MDASH, which stands for Multimodal Agentic Scanning Harness. Quite a mouthful. The hacking headlines covered how it beat Mythos on hacking tests. What's actually interesting is the architecture and bet Microsoft has made. MDASH runs over 100 specialized agents in an adversarial loop. Think of it as specialized defensive squads designed specifically to solve the false positive problem, the junk reports full of nothing burgers that usually drown security teams in noise. MDASH starts with the Auditor, a powerful model that acts as a scout, scanning the codebase and red flagging potential cracks in software. Then comes the Debater. This is a faster, cheaper model whose entire job is to basically play devil's advocate. It reviews every single finding, tearing down weak findings and throwing out any bug that can't be validated. And then finally, you have the Prover. It writes and runs a code to execute the hack, delivering a smoking gun that proves the flaw isn't just a theoretical glitch, but a real-world threat that works and should be patched. A finding that clears all 3 stages is a confirmed threat. In private testing on Windows storage drivers, MDASH caught every single one of 21 planted vulnerabilities with 0 false alarms. But the real mic drop moment happened with CyberGym, which is essentially the gold standard real-world exam for AI security tools. MDASH scored a massive 88.5%, dethroning Anthropic's Mythos from the #1 spot. But the score isn't really the point. Mythos showed how powerful discovery could become. MDASH showed what the next layer has to look like, forcing findings through a system of validation before anyone can act on them. That's the difference between a model race and a workflow race. It's how Microsoft solves the vulnerability inflation gap. And when a better model drops next quarter, Microsoft just swaps it into the harness. The customer's workflow never changes, the output improves automatically, and the model head start / advantage of their rivals simply erodes or is cancelled out. Microsoft isn't obsessed with digging for gold with a better model. They are betting on selling you the shovel, the security factory you'll need to operate those models. But if you think MDASH alone is the only key behind Microsoft's winning position, you aren't looking deep enough. Because a frustrating law in enterprise software is that products don't always win based on being the best in the market. They often win because they're already part of your ecosystem. Think about it. Why does your company use clunky, annoying software when something more modern exists? Most likely because it's already bundled into the invoice and part of your plumbing or technical environment. Walk the security chain and look at where Microsoft already sits and you see their clear advantage. Microsoft owns GitHub, a collaboration platform where developers write and manage code. This is basically the factory floor where code is born. And because Microsoft owns it, they already are holding a wrench when a mistake needs to be fixed. Then they own Azure, a massive cloud computing platform. It provides instant validation and can tell you if a flaw is tucked away in a safe storage room or sitting right next to sensitive customer data. And then Microsoft has Windows Defender, which is a built-in security solution for Windows operating systems. These are the actual locks on the front door. Microsoft doesn't have to guess if a hack might happen. They have eyes on the ground to prove that a threat is real by watching it move in real time. And finally, Microsoft has Sentinel, which is a SIEM, a security, information, and events management platform. It sounds complex, but think of it as the master software dashboard where security analysts track every potential incident, coordinate the response, and shut down a threat before it can spread further. Now, Microsoft doesn't own every stage of the security workflow outright, and to be honest, it doesn't have to. The $3 trillion juggernaut can link finding, proving, and fixing bugs into one continuous self-healing loop. No competitor on the market can replicate this ecosystem without splashing out on a decade-long series of expensive acquisitions. Enterprise security is a $1 trillion market built on one brutal truth. Hackers only have to be right just once. The devs building software and security teams have to be right every single time. AI just made stage 1 of the security workflow and finding vulnerabilities dramatically cheaper and quicker. The news is now obsessed with whoever has the sharpest AI model, but finding potential bugs was never where the value was. The market pays for what comes after: validation, prioritization, remediation, proof, the fully closed loop. Now, the model race will have many winners betting on different stages of the security process. OpenAI has the distribution and is focused on triage. Anthropic has the frontier attacking capability, and Google is pushing into fix and proof stages. You and I both know these labs will trade benchmark victories for years, and every one will make headlines. I mean, even while I was recording this video, Anthropic made the rounds again, sharing that Mythos-class models are being prepared for general public release. We're going to see the floodgates crack wide open. But Microsoft still owns MDASH and the ground that most security teams and even companies operate on. It's the landlord with the ultimate stranglehold on the AI cybersecurity market. So what do you think? Is there any AI cybersecurity software that's really playing on Microsoft's level? Or was Microsoft's bet on the remediation pipeline the wrong move? I think Google's CodeMender is a serious threat to them, but I'd love to hear what you think in the comments.